Hi folks, this is the last video clip that I'm going to do before your final exam, which is in a few days. And the reason that I'm doing this is relatively simple. I have 3 blocks shown here, yellow, orange, and green, and they're moving on a prismatic joint along these 3 tracks. Okay. Now the motion is specified according to these position time plots. Now, first of all, in the problem that we're doing, this location where these are standing initially, this is the 0 location, and then this is padded, so negative in the right to the right and positive to the left, 10 inches to the right, 10 inches to the left. Okay. But when you look at the displacement versus time, you notice that the break points of these curves are at different locations. If I was to write a script file and these breakpoints are all at the same location, for example, everything was changing after 2 seconds, or everything was changing after 3 seconds, etc., then it makes sense to make a single rule and write a few lines of code with a if time is less than 2, then these 3 commands. If time is less than 4, these 3 commands. But here, because these breakpoints are different, if you're going to write lines of code, then it's unwise to have a single rule. We should have 3 rules, 1 for each one of these, and it'll remind you how to associate these rules, because there's going to be 3 of them. The question is what goes with what block. Okay. Now, what I have done here is I've already created all the parts. There's the assembly, but I've not created any joints. So I want to do this thing manually. Okay. So let's click on new mechanism. Let's click on the anchor right there, fixed part, and it says, okay, you don't have a mechanism, so do you want to create one? The answer is yes, and it's going to be called mechanism number 1. And then you select the base. This is the base, and it's going to anchor it for you. Okay. Notice that the anchor sign is right here. You can see that. All right. Okay. Let us create the prismatic joint for the yellow one. So I'm going to create a prismatic joint, and I'm going to call this thing yellow. Let me call it yellow prismatic. I'll just call it yellow. How about that? Okay. Yellow. For the line, okay, for the first line, I'm going to select this line, which belongs to the yellow piece, and this line, which belongs to the track. And for the planes, I'm going to select, for example, this plane and that plane. That makes it prismatic joint. Okay. And the name of it, as you can see, is yellow. It's between the yellow block and the base. Let's do it one between the orange and the base. Okay, so another prismatic. I'll call this thing orange. Orange. Okay, and so for the line, I'm going to select this line which belongs to the orange piece, orange part, and this line which belongs to the base, and that plane from the orange, and that plane for the base. So here is we have our orange prismatic joint. Let's do another one. This one I'm going to call it green. For the line is this line here. For the base, that line. For the plane, this plane of the green one, and this plane of the base, and we say okay. Now notice that 3 prismatic joints have been created. Degree of freedom is 3, and first thing I'm going to do before I'm going to save everything. All right, then we're going to make these things length driven. Okay, of course later on I will put some rules here, but right now I'm going to double click on this, and the name of the joint name is there's the joint name, okay, length driven. Now right now this goes to the right, which means in the negative direction. I'm going to flip this so that it goes to the left. Now the range is from minus 100 inches to 100 inches. I really am not worried about that, because later on I'm going to put a rule. Actually the whole length, the length of this entire base is 20, plus 10 in the left and minus 10 in the right direction. So we just say fine, don't worry about it. Okay, notice that the name of the command, this is the yellow one. And let me remind you that if you look at the yellow is moving in the positive direction. This is why I flipped the direction of that blue arrow, so that it actually moves in the direction that I want. Okay, if you look at the orange one, the green one is actually the one that goes in the negative direction, so we'll worry about that later. All right, that takes care of this. By the way, you can go ahead and change the name of these things in the event that you want. Instead of command 1, why don't we call it yellow? It's easier to keep track of things later on. Yellow. Okay, very good. Now double click on the orange. Right now the orange is also, if you say length driven, it also moves to the in the negative direction. You flip the arrow, you put the cursor at that blue arrow and change it, and fine. And let me change the name of this thing also to orange. It makes it a lot easier when we try to write the code later on. Finally, the green one actually, when we make it length driven, it should go in that direction. Now we have two choices really. One is maybe we make everything go to the left, but take into account the sign, the correct sign in our formulas. That's one option. Okay, I don't know which one is better, so why don't I also flip this thing, and then I take into account when I write the code, I make sure that it's written so that it moves to the right in the negative direction, basically. All right. Okay, obviously mechanism can be simulated. Let me change the name of this last command. Let me change it to green. Okay, very good. So save everything. Needless to say that I can simulate with command, but of course there's going to be 3 sliding bars. Each one of them corresponds to a particular block. So this one is for the yellow one. It goes to 100 inches, etc. So I just close it. Everything worked point here. Now, now we have to write the formulas. Okay, so what we're going to do, these formulas, it's not the same thing that you see here in the one that you're used to. Like here it says formula, but this is a very simple formula. In other words, something that doesn't have an if statement, etc. So what we need to do is we have to go to knowledge where, so the module, and knowledge advisor, and look for the thing that it looks like programming. So it says rule, if X then Y. Now I'm going to do this thing one by one. The first one, I'm going to call it, this is for yellow command. Okay, yellow. All right, now we say okay. All right, now if I need to see this thing right in front of me. So if this is the yellow one, if time is less than 3 seconds, then this goes at the speed of 5 inches per 3 seconds. Okay, so we're going to say if time, there is time, is less than 3 seconds, then okay, the we need the command which goes with the yellow joint. So if I click on all here, we get everything, but I don't want everything. I want only the stuff for mechanism, and there we are. Okay, so for the yellow one, it is this. Remember, I changed the name so that I could see it. So it's this thing that I'm dealing with, is equal to 5 inches over 3 seconds. If you want, if you want, you can put this thing in parentheses. You don't need to. Times time. Okay. Now look at the formula again. If the time is less than 8, so between 3 and 8 seconds, it sits at that location. And that location, by the way, is 5. Okay, 5 inches. So else, if time, if time is less than 5 seconds, that command, the yellow command, stays where it is. In other words, 5 inches, doesn't move. And finally, else, look at the graph. Else, if time is, else we mean anything after 8 inches. 8 seconds. So it's going to be else that command equal to, it start at 5 inches. That's where it was sitting. Plus, it goes at the speed of 5 inch in 2 seconds. 2 seconds. I put in parentheses because it's easier to read. Times time, parentheses. Now this is very important. You don't want to forget this. Time minus 8 seconds. Easy to forget this minus 8 seconds. Okay, good. So we say, assuming that there are no syntax error, we say okay. I don't think there are. So there we are. This is the yellow rule. Okay. Let's do another one. This one I'm going to call it orange. Orange. Say okay. Now I just want the stuff for the mechanism. So click on the mechanism. Only the stuff where the mechanism shows up. And if you look at the orange curve, so the speed is 5 inch over 4 seconds. Okay. So we say if time time is less than 4 seconds, the command is the orange command, this one, equal to the speed was 5 inches over 4 seconds. Is that correct? Let's check this. Yep, 5 inches over 4 seconds times time. Else, if, now let's see. So then, okay, so after 4 seconds, then it's going to go in the opposite direction, in the negative direction, or at the negative. Think about it as negative velocity. So so we have to say if time is less than 6 seconds. Make sure 6 seconds. Yep. The orange command equal to, remember it was at 5 inch location. It was at 5 inch. And then we have to say minus, because it goes in the other direction. 5 inches in 2 seconds, if I'm not mistaken. Let me check this. 5 inches in 2 seconds. Yep. Times parentheses time minus 6 seconds. And finally, after the remaining 2 seconds, you can see that the remaining 2 seconds, it actually let me see now. If you put if you put 6 here, obviously, Let me make sure that this is correct. Let's check this. I am sorry, this should not be 6, it should be 4. Okay, because when you put for time, you put 6 seconds, it's going to be 6 minus 4 is 2 times this velocity is going to be 5 inch minus 5 inch, which is 0. That is correct. And finally, else the orange command is equal to, well, it starts at 0 because you know that at 6 seconds it reaches 0, so it reaches 0 and it goes with the speed of 10 inch in 4 seconds. So it's going to be 10 inch in 4 seconds time, oops, backward, times parentheses time minus 6 seconds. Yep. Let's hope that I didn't make any mistake here. I think that's all right. So we say okay. Yep. And finally we make the rule for the green one. So click on that, change this thing to green. Okay. And click on the mechanism so that only the stuff where the mechanism comes. And we say if time is less than, now here you got to be careful because we have to take care of the signs correctly. Let me see. Okay, so if the time is less than 2, this thing goes, but it goes in the negative direction at the speed of 10 inch in 2 seconds. Okay, so let's see now. It's easy to make a mistake here. Let me make this thing 10 inch in 2 seconds. So this is going to be less than 2 seconds. The third command, the green command, is equal to negative 10 inches in 2 seconds times time. So when this happens, it goes to negative 10 inches, right? So if you put a 10 here, if you put a 2 here, you're going to go to location minus 10. Very good. Else, if time is less than, let's go to that graph again, 6 seconds, it stays there, 6 seconds. This third one, which is the green command, is equal to minus 10 inches because it sits there. And finally, else if then it takes up speed, and it goes back all the way to the 10 inches location to the right at 4 inch, what is that, 20 inches in 4 seconds. Okay, good. So let's see now. Else this command equal to where it was before, which was minus 10 inches, and add to it that speed of 20 inches in 4 seconds times parentheses time minus that'll be what, minus 6 seconds. 6 seconds. Think about it. If the time is 10, 6 minus 10 is 4. 4 times 20 over 4 is plus 20. Minus 10 is plus 10. So it goes back all the way to the right hand side. Okay. Save. So what's going to happen is that this block, the yellow one, is moving to the left and probably stays stationary. I think stays stationary for a short period of time, then it goes further to the left. The orange one goes to the left and then goes to the right and then moves back to the left all the way to the end, to the left side. This one goes to the right all the way to the end Well, goes to the right, all the way to the, stays there for a while, and then in a fast way it goes all the way to the right. At the end of the day, if you didn't make any mistakes, all of these after 10 seconds are going to reach the 10-inch location on the left side of the track. Okay, so let's do it. Let's go back to DMU kinematics. Put a simulation with laws, 10 seconds. I didn't put any sensor, but if I wanted to, I can create position displacement sensors here and then plot it. And I should, of course, get these graphs. Okay, I'm not going to do that. One way to check, after 10 seconds, all of these should be at the left side. Okay. Having said that, the yellow one goes to the left, stays, stops, and then goes to the left. The orange one goes to the left, then goes to the right, and then goes to the left. And the green one goes all the way to the left, stops there, and then all the way to the right. All the way to the right, stops there, and then all the way to the left. Okay, let's see it. That looks right, doesn't it? Let's check that. Check that one more time. Let me put some more steps here. There's something that I didn't like there, but anyway, we'll find out. Yeah, I didn't like this yellow one jumping all the way to the right. So let me do this thing in steps. Okay, so this is fine. As we expected, this one, the green one, is going to the right, no problem. These two are going to the left. Of course, the yellow one has a bigger speed, that's why it's moving ahead of the orange one. Okay, now notice that this green one doesn't go all the way to the right, because actually the 1 inch thickness or the depth of or the size of the green block I'm not taking into account, so it doesn't go in fact all the way there to the 10 plus 10. It goes, oh yeah, it goes to plus 9, I believe, to the 9 inch. We'll find out. Okay. Okay, now if you look at this rule, the yellow one should stays there for relatively for 5 seconds. Okay, for 5 seconds. When it reaches the 8-inch position, okay, there is this 8 inches. Let's see, 8 inches. Yeah, so let's keep in mind that this is 1 inch itself, so this one should go to the right. Oops. I kind of lost track of these, so let's make sure that okay, so just look at this for a second. At 3, when it's 3 seconds, the 3 second, the yellow one should stay stationary, and the orange one should go to the right. Is that what's happening? 3 seconds. There's a problem with this. This is not quite right. You have to find out what's going on, because this should have gone. Oh, sorry. No. Just a second. The break point for these is not the same. At when it reaches 4 seconds, that the orange one goes to the right. We haven't got to the 4 second yet. See, when it gets to the 4-second time, there, the orange one should go to right now. Yep, that's good, that's good, that's good. So let's see, it goes at 6 seconds, it reaches the 0 position. I hope so. 6 seconds, you should reach a 0 position, which means right there where it started. Yeah, it looks good, it looks good. Oh, this one, the problem is here. There's a problem, there's something wrong with our formula with this yellow one, because I didn't like the way the yellow one behaved. The yellow one at 6 seconds, see now, the yellow one at 8 seconds, it should start moving, not 6. Okay, so let's go and check, rewind this thing, let's check our formulas. It's the yellow one that I have a problem with. Yellow one. There, this should not be 5, this should be 8. The yellow one, you see, the yellow one until 8 seconds it says that's 5-inch location. Okay, so I think we have fixed the problem. Let's try it now. The yellow one should go to the left, stays there for a long time, relatively long time, and then goes further to the left. The orange one should go to the left, and then should go to the right, back to the 0 position, and then go all the way to the left. And this green one, go to the right, stay there for a long time, and then very quickly go to the left. So let's try it now. Okay, so let's see it. I put a 200 here so that things don't go very fast. We can see it. I may have to make this thing even bigger. Yeah, that's correct. So remember, this thing was not going, this thing was jumping back to the left of the location. Anyway, you got the picture. Not all of these can easily be combined into a single code. It can be done, but it's a hassle. There is something I was going to do, but I really don't have the time to do it, and I'll leave it to you. What I was going to do, I was going to put a propeller on top of this orange one. So basically we have one more joint. This is this one is going to be a revolute joint, and then obviously there's going to be 4 degrees of freedom. You have to put some physics for the propeller, which means you're going to have a green one for the prismatic, which we already have, another one for the revolute, and I'm not going to do that. I think you have seen enough of these that you can do that, and don't be surprised if you see something like that on the test. All right.